Hello viewers, in my previous video I have given you the basic concepts of arithmetic progression, and today I am going to show you the sums of sequence. Okay, so let's start. Now the first question is, write the first three terms of each of the sequence defined by the following: an equals to n plus 2. So this formula is given to us and we are to find first three terms. So how to do this sum? Here an is given n plus 2 and we are to replace this n by first by 1, then by 2 and finally by 3. So if I replace this n by 1, so a1 will be 1 plus 2. So 2 plus 1 3, 3 1 ja 3. So this is our first term. Second term, you have to replace this n by 2. So if you write a2, we have to write 2 within bracket 2 plus 2. 2 plus 2, 4. 4 2 ja 8. And when you replace this n by 3, you will get 3. Then 3 plus 2, 3 plus 2, 5. 3 5 ja 15. Therefore, first three terms are 3, 8 and 15. An equals to n plus 1. So this is the question. So what we will do? Here it is given an equals to n plus 1. Just like previous sum, replace n by 1, 2 and 3. So a1 will be 1, 1 plus 1 because we are replacing n by 1. So 1 by 1 plus 1, 2. If you replace it by 2, a2 will be equals to 2, 2 plus 1. 2 plus 1 is 3. So it will be 2 by 3. And if you replace this n by 3, we are going to get a3 equals to 3, 3 plus 1. And we know 3 plus 1 is 4. That means 3 by 4. First three terms are half, 2 by 3 and 3 by 4. Now let me do the first part of question number 2. And we are to find first 4 terms of 2 to the power n. Now here already it is given 2 to the power n. So here first term will be 2 to the power 1, replace n by 1, so we are going to get 2. If you write second term will be 2 to the power 2 is 4. For the third term, it will be 2 to the power 3, it will be 8. And for the fourth term, we are going to get 2 to the power 4, which means 16. Therefore, first 4 terms are 2, 4, 8 and 16. This sum is same as this one, so I am not showing. Next sum is n square minus 16. It is already given n square minus 16. So a1 will be 1 square minus 16. We are replacing n by 1. So 1 minus 16, that means minus 15. If we take n equals to 2, so a2 will be 2 square minus 16. 2 square is 4. 4 minus 16 is minus 12. a3, if you take n equals to 3, 3 square minus 16. 3 square is 9. 9 minus 16, it will be minus 7. And if we take n equals to 4, we are going to get a4 equals to 4 square minus 16. That is 16 minus 16 equals to 0. Therefore, first 4 terms are minus 15, minus 12, minus 7 and 0. Fourth part of question number 2, that is 3 to the power n divided by 2 to the power n plus 1. So this question is given to you 3 to the power n divided by 2 to the power n plus 1. So for a1, what we have to do? We have to take n equals to 1. So if you take n equals to 1, you are going to get 3 to the power 1. Here 2 to the power 1 plus 1. 2 to the power 1 means 2. 2 plus 1, 3. So 3 divided by 3, we are going to get 1. If you take n equals to 2, then what we are going to get? 3 to the power 2. 2 to the power 2 plus 1. So 3 to the power 2 is 9. 2 2 ja 4. 4 plus 1, 5. So it will be 9 by 5. If you take n equals to 3, then a3 will be 3 to the power 3 divided by 2 cube plus 1. 3 cube is 27. 2 cube is 8 plus 1. 27 by 9. So it will be 3. And fourth term will be, if you take n equals to 4, we are going to get 3 to the power 4 divided by 2 to the power 4 plus 1. 3 to the power 4 means 3 into 3 into 3 into 3. That means 9. 9 9 ja 81. 2 to the power 4 is 16. 16 plus 1. So it is 81 by 17. Therefore, first 4 terms are 1, 9 by 5, 3 and 81 by 17. As question number 3 is quite similar to question number 2, so I am not showing question number 3. You can do it yourself. I am showing question number 4, and here we have to find the 19th term, and here n is given n minus 2 n plus 3. So here n is n minus 2 n plus 3. Since directly it is given 19th term we have to find, so a19 will be 19, then 19 minus 2 divided by 19 plus 3. So what we have done, just replace n by 19. 19 minus 2 will be 17, and 19 plus 3, 22. If I multiply, I am going to get 323 divided by 22. Let me show question number 5. Find the term indicated in each case. Tn is given as 4 to the power n plus n square minus n plus 1, and we have to find T3. So question is this one. This expression is given to you, and we have to find T3. So directly we can write T3 equals to 4, replace n by 3 plus n square means 3 square minus 3 plus 1. 4 cube it is 64. 3 square is 9 minus 3 plus 1. Now we know all the positive numbers we have to add together. So 9 plus 1 10. 10 plus 64 minus 3. 64 plus 10 74 minus 3. So we got 71. Now see second part of question number 5. Hn is given as n square minus 3n plus 4, and we have to find h10. Now see hn is given and we have to find h10. So just replace n by 10. So it will be 10 square minus 3 into 10 plus 4. 10 square is 100. It will be 30 plus 4. 100 plus 4 is 104 minus 30. So if you subtract, you are going to get 74. Let me show question number 3 of this 5. n is given as n square divided by 2 to the power n, and we have to find a7. So for this formula is already given. So what we'll write, a7 equals to 7 square, because n is 7, it will be 7 square divided by 2 to the power 7. Now 7 square is 49. 2 to the power 7 means 2, you have to multiply 7 times, and you are going to get 128. So 49 by 128 is the required answer. Let me show you the fourth part. In question number 4, it is given minus 1 to the power n minus 1 and n to the power 3. We have to find a9. So an is given. So an here is minus 1 to the power n minus 1, then n cube, and we have to find a9. So a9 will be minus 1, 9 minus 1, because n is 9, and then n cube, so it will be 9 cube, minus 1, 9 minus 1, 9 minus 1 is 8, and 9 cube means 9 into 9 into 9, you are going to get 729. Now minus 1 to the power 8. Remember that minus 1 to the power, if you get any even number, you are going to get plus 1. And if it is minus 1 to the power any odd number, it will be minus 1. Since 8 is even number, so minus 1 to the power 8 will be 1 into 729. So answer is 729. I hope you are understanding this thing. These sums are quite simple. Now let me show question number 6. Here question is, find the first 5 terms of the sequence and write corresponding series given by a1 is given 1 and n is an minus 1 plus 2, where n is greater than equals to 2. So here a1 is 1 given, so no need to find a1. So if n is 2 or more than 2, we have to use this formula. So here if I consider a2 will be a2 minus 1 plus 2, a2 minus 1, a2 minus 1 plus 2. So a2 minus 1 will be 1 plus 2. a1 already we know it is 1. So it will be 1 plus 2. That means it is 3. For a3 we will write a3 minus 1 plus 2. So a3 minus 1 will be a3 minus 1 is 2 plus 2. And value of a2 is, already you know a2 is 3. So it will be 3 plus 2, and 3 plus 2 is 5. Clear? Next one is a4. For a4 what we have to do? a4 minus 1 plus 2. a4 minus 1. Remember that a is here and 4 minus 1. So a4 minus 1 is 3 plus 2. A3 is what? A3 is given as 5. So it will be 5 plus 2 and 5 plus 2 will be 7. And fifth term, it will be A 5 minus 1 plus 2. A 5 minus 1 will be 4 plus 2. A4 is what? A4 we got 7. So you have to replace it by 7. 7 plus 2, 9. Therefore, first 5 terms are 1, 3, 5, 7 and 9. And the series will be 1 plus 3 plus 5 plus 7 plus 9. Now second part of question number 6. Here it is given A1, A2 both equals to 1. An equals to An minus 1 plus An minus 2 and the value of n is greater than equals to 3. Here A1 and A2 both are equal to 1 and for An we have to use this part. Now since A1 and A2 both are known, we will start from A3. So A3 will be A3 minus 1 plus A3 minus 2. Now A3 minus 1 is 2 plus A3 minus 2 will be 1. A2 plus A1. What is A2? A2 is 1. A1 also 1. So instead of A2, I will place 1 plus 1. That will give me 2. For A4, same formula, A4 minus 1 plus A4 minus 2. A4 minus 1 is 3 and 4 minus 2 is 2. What is A3? A3 is given here 2 and A2 will be 1. So it will be 2 plus 1, 3. And for A5, A5 minus 1 plus A5 minus 2. A5 minus 1 is A4 plus A3. A4 is what? A4 is 3 plus A3 is 2. So we are placing 2 and 3 plus 2, 5. So first 5 terms are 1, 1, 2, 3, 5 and the series is 1 plus 1 plus 2 plus 3 plus 5 plus it will continue. Okay, I hope this sum is clear. Now let me show you the next sum, that is question number 7. Here it is given, find the first 6 terms of the sequence whose first term is 1 and whose n plus 1th term is obtained by adding n to the nth term. Just see the question nicely. Here it is given first term is 1. So here I have written first term is 1 and whose n plus 1th term is obtained by adding n to the nth term. Let me repeat. And here it is given, here first term is 1 and n plus 1th term is obtained by adding n to the nth term. Now let me consider n equals to 1. Because a1 is already known, we have to find a2. And if I consider n equals to 1, 1 plus 1 it will be 2. So a2 I can write a1 plus 1. Now we know if it is n plus 1, an plus 1. So its formula will be an plus n. So a1 plus 1. Clear? So a1 is 1 plus 1. 1 plus 1, 2. If n is 2, if I consider n equals to 2, 2 plus 1, 3. So I can write a3 equals to a2 plus 1. Okay, instead of 3, I am writing 2 plus 1. And as per the formula, if it is a2 plus 1, it will be a2 plus 2. So I have written a2 plus 2. Just see, if it is n, this 2 also n. So if it is a2 plus 1, it will be a2 plus 2. And here value of a2 is 2 plus 2, 2 plus 2, 4. So here I have shown a2 and a3. Similarly, try to find the remaining 4 terms. Now let me show question number 8. Write the next term of the sequence 1 by 6, 1 by 3, 1 by 2 and we have to find the next term. Now here 1 by 6, next one is 1 by 3, 1 by 2. So a1 is given, a2 is given, a3 is given. We have to find the 4th term. Now just divide a1 divided by a2. 1 by 6 divided by 1 by 3. So 1 by 6 into 3 by 1. You got 3 and 6 can be cancelled. So you got 1 by 2, which is the 3rd term. Just see. So that means first one divided by 2nd term. We got 3rd term. That means 4th term can be obtained by dividing a2 divided by a3. So a4 equal to a2 divided by a3. We got the logic from here. a1 divided by a2 is a3. That means a2 divided by a3 will be a4. So 1 by 3 divided by 1 by 2. 1 by 3 into 2 by 1. We got 2 by 3. Now the next part of question number 8. Question is 1 by 6, 1 by 3, 2 by 3 and we have to find the next term. Now if you see nicely, Just check here. Here A1 is given 1 by 6. A2 is given 1 by 3. A3 is given 2 by 3. Now, when we multiply A1 by 2, just see 2 into A1, 2 into 1 by 6, we got 1 by 3, that is A2. That means first term, whenever we multiply by 2, we got second term. Now, 2 into A2 will be 2 into 1 by 3, we got 2 by 3, which is the third term. That means first term multiplied by 2, we got second term. Second term multiplied by 2, we got third term. That means third term multiplied by 2, we should get the fourth term. 2 into 2 by 3, it will be 4 by 3. So, the missing number is 4 by 3. Yes, question number 9, 10 and 11, 12, they are almost same. So, I am not showing, I am directly showing question number 13. These sums you can try exactly like the previous sums. Now, for question number 3, what's the question? The sequence n is defined by n equals to n minus 1 into n minus 2 into n minus 3. And we have to show that the first 3 terms of the sequence are 0, but the rest of the terms are positive. Okay, so now here in the question it is given n is n minus 1, n minus 2, n minus 3, and first 3 terms are 0, we have to prove. So if I replace n by 1, I am going to get 1 minus 1, 1 minus 2, 1 minus 3, and we know 1 minus 1 is 0, here it will be minus 1, minus 2, and 0 into something is 0, so whole thing is 0. For the second part, that is if I replace n by 2, I am going to get a2 equals to 2 minus 1, 2 minus 2, 2 minus 3. Here again 2 minus 2, it will be 0, and 0 into something is 0. If you replace it by 3, 3 minus 1, 3 minus 2, 3 minus 3, and 3 minus 3 will be 0. Since it is 0, whole thing is 0. But number 4 onwards, if I replace this one by 4, 4 minus 1, 4 minus 2, 4 minus 3, all are positive. This part is positive, this part is positive, this part is also positive. That means here we got 6. And if I take 5, 6, 7, in all the cases, all the terms will be positive. So, the first 3 terms are 0, but rest of the terms are positive. Let me show question number 14. The Fibonacci sequence is defined by a1 equals to 1, a2 is also equals to 1, and an is an minus 1 plus an minus 2, where n is greater than 2. This is already given. We have to find an plus 1 by an for n equals to 1, 2, 3, 4, 5. a1 is 1, a2 is 1, and for an formula is an minus 1 plus an minus 2 when n is greater than 2. Now, since a1 and a2 already known, let me first find a3. a3 will be a3 minus 1 plus a3 minus 2. So, a3 minus 1 will be 2 plus a3 minus 2 will be 1. a2 plus a1, 1 plus 1. 1 plus 1 will be 2 because a2 and a1 both the values are given in the question. Similarly, for a4, a4 will be a4 minus 1 plus a4 minus 2. That means a3 plus a2. a3's value is known to us, that is 2, and a2 is given 1. So it will be 2 plus 1, 3. Similarly, we can calculate a5. It will be equals to 5. If I consider n equal to 6, a6 will be a6 minus 1 plus a6 minus 2. So it will be a5, it will be a4, and a5 is 5, and a4 already we got 3. So it will be 5 plus 3, that will be 8. Now I have written all these values. Now we are to find an plus 1 by an. When n is 1, it will be a 1 plus 1 by a1. a1 plus 1 is a2 by a1. a2 already you know it is 1. a1 also 1. So 1 by 1, answer is 1. If n equals to 2, then formula will be a2 plus 1 by a2. a2 plus 1 is a3 by a2. What is a3? a3 is 2 divided by 1. 2 divided by 1 is 2. If n is 3, it will be a3 plus 1 by a3. a4 by a3. What is a4? a4 is 3 and a3 is 2. So it will be 3 by 2. If n is 4, a4 plus 1 by a4. That means a5 by a4. It will be 5 by 3. and when n equals to 5, it will be a5 plus 1 divided by a5. That means a6 by a5, it will be 8 by 5. So the required answer is 1, then 2, then 3 by 2, 5 by 3 and 8 by 5. Let me show you the last sum. Here it is given, find the 21st and 42nd terms of the sequence defined by n equals to 0 if n is odd and it is 1 if n is even. Now here you just see n21. Since it is given in the question that whenever it is odd, value is 0, so directly you write 0 since 21 is odd. And T42, since 42 is even number and in the question it is given whenever it is even, answer will be 1. So this answer will be 1. I hope you have understood. This is a very simple exercise. Next day I am going to show you 5.2. Till then, bye bye, take care.